Hello my dear first PUC students, welcome to Deeksha Karnataka YouTube channel. And your final exam is near and you are wondering, sir, nanu ella gotilla, please help us. So don't worry, we are here to help you with all the subjects and also all types of questions, right? So we are starting with 1 marker for physics. Today we will be also giving you all 2-3 marker as well as 5 marker in physics. Every question, all important questions will be discussed. Along with this, we will also give you the model question paper solution and the passing package. Those who have not started studying at all, for them also we are going to give you a passing package, so that if you watch that video, your entire passing marks should be guaranteed. So now we are you should start and you should attempt at least 60+ marks, right? So for that you have to watch each and every video, and if you have not yet subscribed to our channel, don't forget to subscribe to our channel, obviously, and also join the WhatsApp channel. The link of the WhatsApp channel is given in the description section of this video. The PDF of this lecture and all of your first PUC lectures will be shared through our WhatsApp channel, so don't forget to join the WhatsApp channel. And this is a very important part of your life, so from now on you should be a little bit more serious, right? I hope that because most of your first PUC were gone just like that, you have wasted a lot of time. So now at least 10 to 15 days are there between your final exam, first PUC exam. So we will be started with your first 1 marker, the most difficult part where students are struggling. So sit tight, take your notebook if required, take some notes if you want, and let us start with the lecture. So first we are going to discuss each and every paper, every chapter, and each chapter will have 5 MCQs, very important 5 MCQs, and 5 fill in the blanks. So each chapter total 10 questions, that means 14 chapters. We are going to solve 140 questions quickly, right? We will not waste too much time. Let's start. First is units and dimension chapter. Which of the following statement is incorrect regarding significant figures? So significant figures, and you have to find the incorrect statement. That means 3 statements are correct, only 1 is incorrect, and you have to identify that incorrect statement. All non-zero digits are significant. This is a correct statement. Obviously we know all non-zero digits are significant. All zeros between 2 non-zero digits are significant. For example, 2002. So that means these 2 zeros are significant. So this is also a correct statement. The trailing zeros in a number with a decimal point are significant. So if I write, say, 1500 dot, so all the zeros are basically, all these zeros are significant, okay? So the decimal point, if you are writing using decimal points, all the trailing zeros are significant. The power of 10 is counted while counting the number of significant figures. Now if I tell you there is a number, for example, 6.67 into 10 to the power of minus 11. Do we count this 10 to the power of minus 11 as significant figure or not? So this is a scientific notation, and in scientific notation only this number matters. This number is not part of the significant figure. That means this statement is incorrect. So this is the correct answer for this question. So all other 3 points are correct statement, only this one is incorrect statement, and they asked you to find the incorrect statement. So make sure you read the question properly before answering. This can be tricky for you. Now let's move on to the next question. Which of the following physical quantity has same unit in CGS, FPS, MKS and SI system of unit? So CGS means obviously centimeter, gram, seconds. FPS means foot, pound, second. MKS means meter, kilogram and second, and SI system is the standard all accepted system. Now only one quantity that has unit in all same on all units, which is time. Times SI unit or MKS unit or CGS unit, everything is seconds. Okay, so that's why time is the unit which is common across all different forms of unit system. Now next, which of the following physical quantity has not is not a fundamental quantity? So here we have 4 quantities. Out of them 3 are fundamental, one is not. Length, temperature, electric current, energy. Length is a fundamental quantity, temperature is a fundamental quantity, electric current is a fundamental quantity, energy is a derived quantity. Okay, derived quantity means it involves more than one fundamental quantity. So obviously energy is not a fundamental quantity. So easy question. Let's move on. The SI unit of electric current is what? Joule, volt, ampere. So SI unit of electric current, you studied in your class 10th that SI unit of electric current is ampere. Now remember, ampere, A is small letter. If you are writing ampere with capital A, that belongs to the name of a person, the scientist who has contributed towards the current, electricity and lot of other stuff. So that's why ampere, A small, or capital A if you are writing the symbol of ampere. Symbol of ampere is capital A, but when you are writing in full words, it should be A small letter. Now next, the SI unit of solid angle is radian, degree, stray radian, radian per meter. So the SI unit of solid angle is stray radian. It's a complementary quantity, right? We know that it's a complementary unit, and SI unit of solid angle is stray radian. Radian is the unit of normal angle, degree is also normal angle, stray radian is the SI unit of solid angle. SI unit of normal angle is radian, not degree, by the way. So if it is same question is asked, SI unit of normal angle, and if they give you the same option, it will be radian and not degree. Okay, now let's move on to the fill in the blanks. Now we will be solving fill in the blanks. Fill in the blanks can also be tricky at times because some options can be combined together. So if you miss one of the option, there is a chance that 2 answer will be incorrect. Okay, generally 5 questions are given and 6 options are given, so 1 option is extra, so you might make mistake in that. So make sure you are answering them properly. Okay, and when you are answering the MCQ question, make sure you not only mark the correct option, also write it in words. For example, in the previous question, if you get the answer, so do not write 5A. Okay, and later on you scratch it and you said, okay, I don't see A is correct, so C. So in that case, marks can be deducted. So better is scratch everything and write fresh 5C, and also write the option stray radian. This is the correct method of writing. If you write and scratch it, then actually in boards this is not accepted, so you should practice it from now, and whenever you are writing the option, write the entire option correct. Okay, correct option completely. Do not write only 5C. Okay, because I have seen students, what they do know, 5A stray radian. They think that they are smart, so they are answering 2. If option A is correct, I will get the marks. If option C is correct, also I will get the marks. This is wrong and you will not get any marks. Okay, if you write it like this, you will not get any marks. You have to write the correct question number, obviously the correct answer, and the option as well. Okay, this is how you should write the MCQ questions. In the fill in the blanks, you have to mention the question number and the correct option completely in words to get the marks. You don't need to write the entire fill in the blanks, but you just need to write the answer, question number and the answer. That is sufficient. You do not need to write completely. So 6 dash is a basic physical quantity. Let's see: strain, plane angle, temperature, frequency, significant, stress. So temperature is a basic physical quantity. It's a basic quantity, right? So temperature is a basic physical quantity. In a number, the zeros between 2 non-zero digits are significant. Okay, so as I mentioned, zeros between 2 non-zero digits, 2002. Very good year. So in a number, the zeros between two non-zero digits are significant. So this is the answer. Now question number 8, dash is a supplementary quantity. Supplementary quantities, there are two supplementary quantities, angle and solid angle. Okay, so if you see here, only plane angle is mentioned. So plane angle is a supplementary quantity. So plane angle is a supplementary quantity. The physical quantity that has neither a unit nor a dimension. So it does not have any dimension. Dimensionless quantities are basically obviously unitless quantities. There are few exception as well. For example, plane angle is a dimensionless quantity, but it has a unit. Okay, the physical quantity that has neither a unit nor a dimension is given all the options. It is strain. It is strain. Strain is a quantity which does not have a dimension nor has a unit. Stress, by the way, has a unit and it is not dimensionless. Strain is a quantity which does not have any dimension nor it has any unit. The physical quantity having the dimension of m to the power of 0, l to the power of 0, t to the power of -1. So it is per second. So the unit is per second. M is 0, L is 0, all other fundamental quantities are 0. So only t to the power of -1. That means the unit is per second, right? Per second, or it is basically also can be written as hertz. So hertz is also per second unit. And what is this quantity? This is nothing but our old friend frequency. Okay, so frequency is the correct answer. Sorry for this, frequency will be correct answer. Right, now let's move on. A body, now we are moving into motion in 1D, also called motion in a straight line. To save some space, I have written motion in 1D. Many colleges, as you are aware, they also teach it like motion in 1D. That was the name of the chapter in old generation. Now they have changed the name to motion in a straight line. Same chapter, same concept, only I have shortened the name so that I can save some space. Okay, a body cannot have a constant speed and varying velocity, an acceleration and a constant speed, a uniform velocity and varying speed, a non-zero speed and a zero acceleration. Now first let us start with the first option, a constant speed and varying velocity. Is it possible? Yes, quite possible if an object is moving in a circular track. Okay, each and every point with a uniform speed. Suppose an object is rotating in a circular track with uniform speed. Uniform speed means the magnitude is constant. Okay, you are cycling in a circular park, suppose at 10 km per second. So your speed is constant, but velocity, is it constant? Velocity is changing each and every point. The direction of motion is changing. So direction of motion changing means velocity is also changing, right? So if the object has a constant speed, it does not necessarily mean it will also have a constant velocity. Velocity can change because velocity is a vector quantity. It depends on direction. So if the speed is constant, velocity can change based on the direction. So this is this is possible, so it can be possible. So we are trying to find which is not possible. Cannot have means which is not possible. So this is quite possible. An acceleration and constant speed. Again, circular motion, it has an acceleration which is pointed towards the center. We already know that in our future chapters we have studied it, right? So this is called centripetal acceleration. Centripetal acceleration is possible, and as the object is moving in a circular track, it can have acceleration, but its speed is constant. So this is quite possible. So again, acceleration and constant speed is still possible. Uniform velocity and varying speed. What is velocity? Uniform velocity means it's moving in a straight line path. Uniform velocity means it's moving in a straight line path, and also its magnitude is same. Now what is the magnitude? Magnitude itself is speed. So if v is constant, that is velocity is constant, okay, speed will also be constant. Okay, if velocity is constant, speed will also be constant because the magnitude of velocity is speed. So if velocity is uniform, that means it is moving in a same direction with a constant value, then its speed has to be constant. Okay, so this is not possible. Very tricky question. Okay, uniform velocity and varying speed is not possible. Only thing that is possible is constant speed but varying velocity. Vice versa is not possible. Non-zero speed and zero acceleration. Obviously non-zero speed object can move with zero acceleration with a constant speed. Any object moving in a constant speed and constant velocity, it can have zero acceleration. So non-zero speed and zero acceleration is quite possible. So only thing that is not possible is uniform velocity and varying speed. Very intelligent question. Make sure if you get this question in your final exam, make sure to answer it correctly. Now question number 2, the slope of the tangent drawn to position time graph at any instant gives. So the slope of tangent drawn to position time graph. Suppose this is the position time graph. This is position, this is time, and if you draw a graph you may get like this. The tangent drawn, okay, and you are trying to find the slope. Slope means if you extend this line, whatever angle it makes, and you calculate the tan theta, that is called slope. Or in other words, if you take two intervals, okay, and if this is say delta s and this is delta t, okay, the slope is basically delta s by delta t. Okay, you will study it in a straight line chapter in your mathematics if you have not yet. Now slope basically represents the change, how the rate of change, okay, rate of change. So here as you can see, delta s by delta t is nothing but rate of change of displacement. So it basically gives the instantaneous speed. It gives the instantaneous speed. Okay, here it will give you instantaneous velocity. Speed is not mentioned. So because it is position, so position means it will be instantaneous velocity. If it is displacement, then it gives speed. Okay, because position itself is a vector quantity. So if you are finding the time rate of change of position, then you will get a vector quantity, another vector quantity, that should be velocity. Okay, not average velocity, not average speed, obviously not instantaneous acceleration. Okay, so position time graph gives you velocity. Velocity time graph, the same question is asked with the velocity time graph, then you will get acceleration. If you don't understand, try to draw the graph, try to figure out what is slope, and from there you can find what quantity they are referring to. Right? Next question, the distance time graph for a particle in motion as shown in the figure. The maximum instantaneous velocity of the particle is around the point. So here as you can see, here we have a graph. So A, B, C, D. They asked you where is the instantaneous velocity is maximum. So instantaneous velocity will be maximum where slope is maximum. So if you try to find slope over here, it is almost 0. So even if you take the time t, it is almost 0. At this point, this will be the slope. So how to find a slope? You take a tangent, draw a tangent, you take this time and try to find what is the displacement. Similarly, here also you can calculate it. So this will be the slope. Okay, it does not matter the tangent has to be like this, it can be like this as well. Now you can see that for same time interval, the distance traveled is maximum for the point C. Okay, the distance traveled is maximum for point C. So if you try to draw the small triangle, keeping the base height same, if you keep the base height same, whoever has maximum distance traveled, that will give you the maximum velocity. So instantaneous speed is maximum at C. Now remember, here the options are not given properly, A, C, B, D, that is the order. So you have to mark the correct answer, which is this C, not this C. Okay, so this is also a trick question, so make sure you answer properly. The correct answer is point C, not option C. Clear? Let's move on. When a body thrown vertically upward, it will take time t to to reach its highest point, then the time taken to return to ground. So here we have an object which is thrown vertically upward. So it goes to some height, say capital H, and then it falls back to the ground again. So if the time taken when it is going up is say T1 and time taken by it when it reaches ground is T2, then from the conservation of energy it can be shown that T1 is actually equals to T2. So the time taken to go up is equals to time taken to come down. So T1 must be equals to T2, and the time taken to return to the ground is again T. So whatever time it takes to reach the highest point, the same time it will take to reach the ground. So it will be T. And if the question is total time taken will be T plus T, that is 2T. This is the total time taken. But if it is only about the time taken to reach the ground from the top, it will be same as the time taken by it to reach from the ground to the top. Okay, here it is mentioned the time taken to return ground. So return word is very important over here. So return ground means top to ground. Okay, so it will be same as T. So make sure you read the question before answering. Next, the area under velocity time graph represents displacement, average speed, uniform acceleration, average velocity. So suppose we have a velocity time graph. So this is V, this is T, and if you calculate the area under the graph, we have done that. So what does it represent? It represents the area under the graph represents the displacement. Okay, so it represents the total displacement. Okay, not position, not speed or velocity, it represents the displacement. Let's move on to the fill in the blanks. The shortest distance between initial and final position of a body in motion is called dash. The shortest distance between initial and final position of a body in motion is called velocity, uniform acceleration, displacement, distance traveled, scalar, downward. So obviously the minimum distance is called displacement. So this is displacement. Speed is a scalar quantity. If a body has equal changes in velocity in equal interval of time, then the body is said to be uniform acceleration. Velocity change is uniform, so the acceleration will also be uniform. The slope of position time graph of a body in uniform motion. So uniform motion position time graph is a straight line, and the slope will give you the velocity. The slope will directly give you velocity, not instantaneous velocity, because it's an uniform motion, so the graph will be a straight line graph. And in case of straight line graph, you can easily calculate the velocity. It will be constant no matter where you take. Okay, it will always be constant and you will get the constant velocity. Now, a body moving under Earth's gravitational field, the direction of acceleration is always. So if you throw an object upward, where is the direction of acceleration? Acceleration due to gravity always acts towards the center of the Earth. So whenever an object is moving under the effect of gravity, the acceleration will always be downward. So correct answer is downwards. Easy. Let's move on to the next chapter, motion in 2D. Again, I am using the old name, and the chapter is motion in a plane. Okay, the correct name or current name is motion in a plane. Again, to save some space, I am using motion in 2D, and also it looks cool, right? Let's start. Which of the following is not a vector quantity? So this chapter also talks about vector and scalar. So here we have some scalar, some vector. So which of them is not a vector quantity? So three of them are vector: work, impulse, displacement, momentum. Now displacement is a vector quantity, momentum is a vector quantity. Now between work and impulse, impulse is also type of force, so impulse is also a vector quantity. Only not vector quantity is work. So correct answer for this question will be work. Remaining all three quantities are vectors, so correct answer will be work. Okay, work is the scalar product of force and displacement, so we know that. So work is a scalar quantity. Next question, if a vector is multiplied by a positive scalar, the resulting quantity. So if you multiply a vector with a positive scalar, okay, the resulting quantity is a vector quantity. Okay, so it will be a vector quantity, its magnitude will increase. So obviously it is not a scalar. A vector having same direction as initial vector, yes, because you have multiplied only a scalar quantity. So suppose the vector is A, now you multiplied this with the scalar x, so the vector direction will same as A, only the value will increase. So it is a vector having the same direction as initial vector. A vector having different direction of initial vector, obviously this is not correct. A scalar, again scalar is not correct. So when you multiply a vector quantity using a scalar, its magnitude increases or decreases based on whether it's a whole number or a fraction. Okay, if it's a fraction, magnitude can decrease. So magnitude will change, but the direction will remain the same. Magnitude will change, direction will remain the same. Next, the resultant of two vectors acting at a point is minimum. The resultant of two vectors acting at a point is minimum if they are in the same direction, that is 0-degree angle, perpendicular to each other, that is 90-degree angle, making an angle 120-degree with each other, or opposite to each other. Suppose we have a vector, say A vector, and we have a vector, say B vector. If they are in the same direction, then they will have maximum value. Okay, so suppose this is 5, this is 7, same direction, so they will simply add up, right? Now how can they have the smallest value? The smallest value will be when they are in the opposite direction, not necessarily they have the same magnitude. Now in this case, suppose this is A vector, this is B vector. Okay, what is the addition of these two vectors? Because they are in the opposite direction, you have to subtract the smaller vector from the larger vector, so that will be giving you a 2 vector in this direction, right? The resultant will be in this vector in this direction, so this is the resultant. So resultant will be minimum. Resultant will be minimum when the angle between them is 180 degrees. No doubt about it. So opposite to each other. Okay, when two vectors are opposite to each other, you will get the minimum resultant, and you will get the maximum resultant when they are at the same direction. Any other angle, the resultant will be between minimum and maximum. Any other angle, the resultant will be between minimum and maximum. Now, statement based question, vector addition is commutative. Two vectors may be added graphically using triangle law of vector addition. Okay, commutative means, suppose you are doing A plus B, okay, or you are doing B plus A, both should be same, right? This is the principle of commutation. Okay, commutative means if A plus B is some value, you will get B plus A, you will also get the same value. Now if you use the triangle law, suppose this is A, this is B, then this triangle should give you the side resultant, right? Now if you see that, it does not matter, because both have fixed direction, it does not matter the order you take, you will always give you the angle between the vectors is also fixed, right? Because for given two vectors, the angle between them is fixed. So no matter if you draw B first and then A, okay, you will get always the same resultant. Resultant should be same. Okay, it is not triangle method, by the way. Triangle method, it has to be drawn one after another. So does not matter if you draw, suppose B first, then A first. Okay, you will get the resultant in the same direction as this. So resultant will always be in the same direction. So no matter the order you take, and because they can be added in the triangle, the sides of the triangle are fixed. So that means both statements are true, and statement 2 is correct explanation of statement 1. So option A is correct. Okay, triangle method is a geometric method. Triangles, if two sides are fixed, the third side will always be fixed no matter what order you draw them. Okay, that's why vectors are commutative in nature. Next question, for minimum range of a projectile. So this chapter also includes projectile. Okay, we will solve some projectile based questions in 2-3 marker question. So the maximum range for a projectile, the angle of projection should be, the maximum range is when the theta is 45 degree. The range is maximum. Okay, so if range is maximum, theta should be 45 degrees. So correct answer is first option, option A, 45 degrees. Now next, and what about height? When the height will be maximum? Height will be maximum if you throw it straight. Okay, height will be maximum if you throw it straight. Okay, so this is H max. Okay, so some teachers tend to give you a question where they will change the question. They will say at what angle of projection height will be maximum. So height will be maximum at 90 degrees. Range will be maximum at 45 degrees. Now next, a vector with zero magnitude is called a null vector. Okay, a vector with zero magnitude is called null vector. So you know that answer. So we just, and whenever you are answering, fill in the blanks, try to mark the correct answer that you have already answered it. Okay, so that you keep a track of which options are already used. All options can be used only once. The splitting up of a vector into 2 or more components are called resolution of vector. So when you split up a vector into 2 or more parts, they are called resolution of vector. Suppose there is a vector like this, we split it up along x-axis, we split it up along y-axis, and this is called resolution of vector. Okay, the resultant of 2 vectors is maximum if they are acting in the same direction or at 0 degree angle. So resultant is maximum at 0 degree, minimum at 180 degree. Okay, so they are acting in the same direction. If they are acting in the same direction, the magnitude is maximum. Dash velocity remains constant throughout the motion of a projectile. Okay, so projectile, if you throw a projectile, there we have 2 velocity components. One is horizontal, one is vertical. So horizontal component of projectile remains constant throughout the motion. So horizontal component remains constant. Okay, so horizontal component remains constant. Question number 10. In uniform circular motion, the body moves in a circle with constant speed. In an uniform circular motion, a body moves in a circular path in constant speed. It's not constant velocity, not constant acceleration. Only speed is constant. Now, if you want to download the entire PDF of this lecture, don't forget to join our WhatsApp community. The link of the WhatsApp community is given in the description section of this video. Also, if you have not yet subscribed to our channel, don't forget to subscribe to our channel, because all the PU1 related coverage will be coming soon in our channel exclusively. Also, when you move on to PU2, your KCET related queries, KCET related all preparations as well as your PU2 board preparation will be done on our channel. So don't miss out on this. Please subscribe to our channel and click on the bell icon so that you don't miss out on any notification. Now next, laws of motion. So now we are moving into the another chapter, laws of motion. Here we have 3 laws of motion of Newton. First question: no force is required to keep an object moving in a circular motion. So if you want to keep an object moving in a circular motion, you need a force which is called centripetal force. So this is incorrect statement. An object moving in a straight line with constant velocity. Now this is the first law of motion. If an object is moving in a straight line with constant velocity without any friction, then it will continue to move with the same velocity in the same direction. So this is where you don't require a force. So this is the most commonly, this should be the correct answer. Let's check the other option. So once you find the correct answer, you should check the remaining options once as well. An object moving with constant acceleration. If the object moves with an acceleration from second law of motion, we need to provide it with a force called F is equal to ma, further equals to ma. So this statement is also incorrect. Next, both A and B. Both A and B again incorrect. A is not correct. Only B is correct. So both A and B is also not correct. right? Let's move on to the next question. What is the term for an object's tendency to resist changes in the state of motion? So for example, what is the name for your tendency to not to study? Okay, so you are wasted almost 1 year and you are hardly studying. You are mostly busy playing free fire, cricket, etc., etc., watching games, watching reels on Instagram, on YouTube. Now you realized, okay, I have to study. So that, what is the state of you? Okay, it is basically it's not you, it's called inertia. Okay, it's present in every one of us. Okay, we do not tend to move from whatever we are doing to something new. Okay, so it is called inertia, okay, of study. So you don't like to study. If you are studying, you keep on studying. For example, right now you are studying with me, so you will keep on studying till this lecture is over, right? So inertia of motion, inertia of rest. So that's basically when some object is at rest, it does not tend to move, which is basically inertia of rest. And if an object is moving, it refuses to stop because it is called inertia of motion. Next, when object A exerts a force on object B, what force does object B exerts on object A? So Newton's third law of motion, if object A exerts a force on object B, same force will be exerted by object B on object A. So equal force in the opposite direction. Okay, equal and opposite force, obviously pair of forces. If you push a wall with the force F, the wall will push you back with the force F, but in the opposite direction, right? So if you apply force F in the wall will push you back with the opposite force, same amount. So F equals to, so F1 equals to minus F2. That's how we write, right? So it's an equal force in opposite direction. You can check the other options, lesser force in the same direction, greater force in the opposite direction. Both are not correct. Next, rocket works on the principle of conservation of energy, momentum, mass, all of these. So this is a little tricky question. So rocket, we sometimes say that rocket science, or with something which is easy, we say this is not a rocket science, because rocket science is one of the most complicated science. Okay, rocket science is something which is very, very complicated, and it works on the principle of conservation of energy, conservation of momentum, conservation of mass. Everything is included in it. So all of these should be the answer. Okay, even though mass is not directly conserved, but we have to account for rate of change of mass. We have to account how the energy is transferred, also how momentum is transferred. So everything has to be accounted for. So that's why when a rocket moves, we have to consider everything: energy, momentum, mass, everything. Now, a cyclist bend while taking a turn in order to, so if you are someone who drove the cycle in some turns and not in a straight road, so when you are taking a turn, you will realize that you take slight bend towards the direction where you are bending. So what is so? Because you have to provide necessary centripetal force. You may have seen MotoGP bike race, okay, where the drivers, when driving on a fast track, they exactly bend and touch the ground, okay, almost touch the ground using their legs. Okay, they have protective gears on their legs, so it does not harm them, but you don't try it on your own. So when they take the bend at the sharp edges or the corners, okay, they bend, almost touch the ground. Why? Because when you are taking a turn, you require a centripetal force, okay, and that centripetal force is provided by a component of your body weight, okay. And in case of bikes, the weight of the driver as well as the weight of the bikes. Cycles weight is not that high, so you do not get too much benefit of that, okay, but you get a lot of support from your own weight. Otherwise you will skid. If you try to take a turn without bending your body, you will skid, or slowing down. If you slow down, this fine, but if you don't slow down, if you try to cycling through in a curved road, okay, at high speed, your cycle will skid and you will make some accident, okay. You will your hands will broken or legs will broken, so don't try it. So it basically to provide the necessary centripetal force. So whenever circular motion is happening, there has to be someone who has to provide the centripetal force, okay. In this case, your body weight, component of your body weight, provides the required centripetal force. Now let's move on to the fill in the blanks. Dash is a measure of inertia of a body. So mass considered to be a measure of inertia of a body. So heavier the mass, higher the inertia. So mass is a measure of inertia of a body. When no external force is applied on a system, its total momentum. So no external force means isolated system. So total momentum should be constant or conserved. Total momentum should be constant or conserved. Next, a force acting for a short duration is called impulse. So if you apply a force on an object for a short duration, is called impulse. For example, when Virat Kohli hits a ball, it goes to the boundary, outside the boundary, right? So what happens is that the force that is applied on the ball is very small. Okay, the duration of the contact is very small. It just touches the ball and the ball immediately goes towards the boundary. So that is an example of impulsive force or impulse. It is also called impulse, right? So impulse is a force which acts for a very, very small duration. For example, in any sports, many of the sports, the impulse is very, very essential. For example, cricket is one of them. Okay, in America they play baseball, or even in tennis you use the tennis ball. When you are hitting the tennis ball, that is also impulse. Okay, in footballs also, the ball is coming, you just touch it and the ball goes to the goal. That is also an example of impulses. Impulses are a lot of examples of impulse. Okay, at equilibrium, net force on a body. So if the body is in equilibrium, net force is 0. Okay, so net force in equilibrium should be 0. So impulse is done, 0 is also done. Next is the SI unit of spring constant. SI unit of spring constant is Newton per meter. SI unit of spring constant is Newton per meter. Spring constant K. Okay, so how much force it is applied per unit displacement, that is called spring constant. Okay, so force is K into X, right? So spring constant is Newton per meter, not Newton meter, Newton per meter. Next, work, energy and power. Another chapter we have completed. So many how many chapters we have completed? 4 chapters completed. 5th chapter is going on. A particle made to go around a circle with a constant speed with the help of a rope. The work done by the rope. So you tie something on a rope and you rotate it on your head or like that. This, okay, this all of us have done it at some point of time. That was a very childish game, and we were child when we were doing it. Okay, we all tie something on a paper. Do not try with the rock. Rock might go out of the rope and it might hit someone, but you can try it using a pen or pencil and you rotate it, right? We all have done it. So that is basically a no work force. So basically you are not doing any work. Okay, so it is actually 0. The work done, because a circular motion, the starting point and ending point are generally same. So when you are rotating something, okay, you are starting at the lower point and when you are rotating it, it again ends up in the lowest point after you finished it. So work done is still 0. So work done to rotate a rope, object tied to a rope is 0. Next, work performed on an object does not depend on the displacement, the force applied, the angle which the force is applied to the displacement, initial velocity of the object. So obviously, what is work done? Work done is F into S into cos theta. So when you apply a force on an object, okay, it depends on the force, it depends on the displacement, and it also depends on the angle theta. That means the work performed on an object is independent of initial velocity of the object. In the formula there is no velocity involved. That means it does not depend on the initial velocity. It depends on force, it depends on displacement, it depends on the angle as well, but does not depend on velocity, right? Now next question. Which of the following is an example of positive work? So we sometimes say positive work, negative work, okay, something which affects us, but in physics the positive work and negative work is something different. So if you apply a force on an object, suppose there is an object, you apply some force on this object, and if the object moves in the same direction of the applied force, then we say this is a positive work. But if somehow the object moves in the opposite direction of the applied force, this is force, this is displacement. So if the displacement is in the opposite direction of the applied force, then we say this is a negative work. For example, when you carry some object from ground floor to first floor. Okay, when you carry an object, suppose you are carrying a bag of books from your ground floor to first floor. So in that case, whatever work that you are doing, the work that is being done by the gravitational force always acts in the downward direction. Okay, mg, and the displacement that is happening in the upward direction, because you are carrying the book from down to up. So in that case, whatever work is done by the gravity is actually negative. Okay, the work done by the gravity is negative. So here, so which example of positive work? Force applied in the same direction as displacement. So if you apply the force and displacement happens in the same direction, we say this is a positive force. If it is in opposite direction, we say negative, positive work. If the force applied and displacement are in opposite direction, then it is a negative work. Clear? If a light body, light means not the light bulb, light means not heavy. Okay, if a light body and heavy body have same kinetic energy, then which one has greater linear momentum? Now this can be tricky if you do not know a formula. So I will teach you the formula. Okay, so what is the relationship between kinetic energy and momentum? First of all, what is momentum? Momentum is mass into velocity. Right, we all know that easy formula. So momentum is mass into velocity. What is kinetic energy? Kinetic energy is given by half mv square. Right, if you don't know, you should know it now. So kinetic energy is half mv square. Momentum is mv. So as you can see, both are related to mv to some extent. Now how can we relate momentum and kinetic energy? So for that, what we can do, we can multiply another m over here so that it becomes m square, and we can divide the extra m in the division, right? So it still remains half mv square, but we can reorganize it. Now what we can do, we can write this as 1 by 2m mv whole square. Right? Now what is this mv? This mv is nothing but p. So it will be 1 by 2m p square. Right? Now we have found the relationship between momentum and kinetic energy. Okay, do the cross multiplication and you get p square is equal to 2mk, or p is actually equals to square root of 2mk. This is a very important formula, not only in your PU1 but also this formula will be handy in your PU2. So when you move to second PUC, that this formula will still be important. Okay. So now they are asking you that a light body and heavy body, both of them have same kinetic energy. Who has higher momentum? Okay, so momentum of light body is equals to square root of 2m light into k. K is same, and momentum of heavy body is p heavy equals to 2m heavy into k. Now if you divide these two quantities, you will see that k is constant, so they will cancel and you are getting m light by m heavy. Now who is bigger? So suppose light is 1 kg, heavy is 10 kg. So basically you will see that the momentum of heavy is greater than momentum of light. Okay, momentum of heavy will be greater than momentum of light because they have same kinetic energy. Okay, momentum of heavy will be more than momentum of light. Okay, so heavier body will have greater momentum. Now same question can be asked in terms of kinetic energy. Same momentum, who will have higher kinetic energy? For kinetic energy it will be opposite. You can calculate from this relation. Okay, k is equal to p square by 2m. So whoever has lighter body will have actually higher kinetic energy. Kinetic energy depends reversely on mass and momentum depends directly on mass. Okay, square root of mass, but direct proportionality. So direct proportionality means higher the mass, higher the quantity. Inverse proportionality means higher the mass, smaller the quantity. Okay, so for kinetic energy it will be reverse. So remember this, if the same question is asked in terms of kinetic energy, okay, same momentum, who will have higher kinetic energy. So whoever has smaller mass will have higher kinetic energy. So remember that this is a very, very interesting and important question. Now next, which of the following statements is true? So 5 statements are given, one of them should be true. Power is the rate of doing work. Okay, power is the rate of doing work. Yes, power is work divided by time. Okay, right? So power is rate of doing work. So this is correct statement. Energy is the rate of change of power, which is not correct. Energy is basically capacity to do work. Okay, that is called energy. Energy and power are same thing. Work is the rate of change of force, which is again not correct. Work is force into displacement. Force is the rate of change of work. Force is rate of change of momentum, not work. So only correct answer or correct statement is this one, option A. Right? So all the MCQs are done. Now let's move on to the fill in the blanks. Work is dash of force and displacement. Okay, it's a scalar product. Okay, it's a scalar product. Work is scalar product of force and displacement. Okay, or scalar multiplication. So here scalar product is given, so scalar product we will answer. When work done is 0, then the speed of a body remains. So if work done is 0, speed is constant. So no work is done. So if you want to move an object, suppose you are pushing a car. Okay, if you are doing some work, then only the car moves. Okay, if you are not applying any extra force, the car is static. So if similarly, when the car is accelerating, you have to apply some force, and based on the force, you will get to do some work, right? So work done is 0 means the velocity is constant. The total mechanical energy of a system is conserved if the forces doing work on it are. So first of all, we have answered constant velocity. Constant one is done. Now this is very interesting question. The total mechanical energy of a system is constant or conserved if the force doing work on it, is it 0? No. Even if the force acts on it, it does not necessarily to be 0. 0 is not correct answer. Yes, if force is not acting, energy is conserved. But even if there is a force, it still can be conserved if the forces are conservative. If the forces are conservative in nature, if forces are conservative, the work done, the mechanical energy of the system can be 0. For example, gravitation. Gravity is a force which is a conservative force. So in case of conservative force, suppose I took this object from first floor to second floor, and even if I drop it from second floor to first floor, okay, I will get back the exact amount of work. So the total mechanical energy will be conserved. Total mechanical energy is potential plus kinetic. Potential plus kinetic, total mechanical energy will be conserved if the force is conservative. So correct answer is conservative. In an inelastic collision, the dash does not remain constant. So in inelastic collision, kinetic energy is not constant, momentum is still conserved. Momentum will still be conserved, but kinetic energy will not be conserved. The rate of doing work is called, so here it is kinetic energy, rate of doing work is called power. Rate of doing work is called power. Okay, now let's move on. Now this is a tricky chapter. You might face some difficulty in answering questions. System of charges and particles and rotational motion. System of particles and rotational motion. So let's continue. Choose the correct diagram which shows the direction of angular velocity of a rotating disc. So here, as you can see, the disc is rotating in this particular direction. Right, the disc is rotating in this particular direction. Each of the disc is rotating in this direction. Now how to find the direction of rotation or angular velocity, how to find it? First of all, you have to curl your fingers in the direction of rotation. So if it is rotating like this, you have to curl in the direction of rotating rotation direction, and then your thumb will point that vector. Okay, so in this case it is rotating in this direction. If it was rotating in the opposite direction, then obviously it will be opposite, right? Remember that curl your fingers in the direction direction of rotation. So in this case you have to rotate in this direction, and then your thumb will point in the direction of angular velocity. So option C is correct. So here it is slightly curved, so that's why you have to adjust your fingers, and as you see that the angular velocity should be outward, not tangential, not inward, and not towards the diameter. Okay, it should be outward, and only one outward diagram is shown over here, so that will be the correct answer. Now let's move on to the next question. A body rotates with the constant angular momentum. So constant angular momentum means what is the relationship? Torque is 0, torque is minimum, torque is maximum, torque is independent of the angular momentum. Now we know that torque of a body is related to angular momentum as dl by dt. So differentiation of angular momentum with respect to time. So if L is constant, we know that differentiation of a constant term is 0. So torque will be 0, right? You have learned basics of differentiation, right? So that means if it is a constant, then ddt of C is 0. So because L is constant, that means torque will be 0. Now next question. A seesaw is balanced with a child on each end. What happens if one child moves closer to the fulcrum? Seesaw will remain balanced. The side where the child moved will go down. The side where the child moved will go up. The seesaw will start rotating faster. So first of all, seesaw is the game that we have played when we are a kid, right? So one child is sitting over here. Pardon my drawing, I am not super expert in drawing. Okay, so this two childs are sitting like this, and suppose one child suddenly decide, okay, I don't want to stay over here, I want to move closer to this. So this child moved over here. Now what will happen? So this child no longer is there, it is moved at this position. So what will happen? So first of all, what is the relation? So if this is the distance, suppose capital L, and this distance is small l. Okay, now remember that it basically works on the principle of a moment of force. Now what is force here? The force here is mg, and assuming both of them have same mass, okay, so both will have same force. Now in which side the moment of force is more? So because the length is more in this case, the moment of force mg into L will be more for the side where child is far away. Okay, both of them are of yours. So suppose you and your friend are doing, unless one is very fat, one is very slim, this logic will still applicable to most of the cases, right, except few particular cases. But if you remember that assuming both of them have same mass, then what we can say, because the distance is small, moment of force decreases on this side. So that means this side should go up, and because higher moment of force in this side will go down. Okay, so on the side where child moved closer to the seesaw, that side will go up. So the side where the child moved will go up. The side where the child moved will go up because it is proportional to mg into L, right? Because L decreases, so force should decrease. The moment of force should decrease, right? Now next question. Some regular objects are listed in column 1 and their moments of inertia are listed in column 2. Identify the correct match. Now in this case there can be some tricky matchings, but remember that at least if you find one of the correct matches, at least one of the correct matches, there is a high chance that will be a unique match. Unique match means, for example, if you see all the options, there are few cases where only one option is given, one match is given. For example, in this case 1 is matching with B. Now if you can find 1 is matching with B, if that is correct, then you do not need to find other two matches. You should be sure that this is the correct answer. But in some cases you will find that matching, there are two different matches. For example, 3 is matching with A is appearing twice. So if you see that 3 is matching with A, then you will say either option B or option C is correct. So first try to do at least one match. So solid sphere along any diameter. Solid sphere is like this, along any diameter the moment of inertia is 2 by 5 mr square. 2 by 5 mr square. So 1 is matching with B. Okay, 1 is matching with B. So we know the answer. I will not answer it yet. We will try to find more matches if possible. Thin circular disc at its center perpendicular to its plane. Thin circular disc is easy, which is mr square by 2. So this is matching with C. Okay, next, hollow cylinder along the axis. So obviously one is left, that is it should be matching with A, right? So as you can see, even if you don't know hollow cylinder, if you know the sphere and the circular disc, you should be able to answer. Now for circular disc along the diameter, if circular disc along the diameter they have given, it will be a m r square by 4. There is a table given in your textbook. You should at least have 4-5 of them, you should remember. Now if you see that 1b is a unique match, 1b is a unique match, so that should be the answer. So even if you have not found 2 and 3, if you have found that option B is 1 is matching with option B, then you should know that this will be the correct match, right? So try your luck, and if you find the correct match, you should be able to answer. Matching question are very common nowadays, okay? So you should practice some of the matching question as well. Now next, the kinetic energy of a rotating body is. So kinetic energy of a normal non-rotating body linear motion, kinetic energy of a body in linear motion is given by half mv square, right? This is the kinetic energy in linear motion. Now we have to replace the individual quantities m and v with rotational analog. What is the rotational analog of mass? Rotational analog of mass is moment of inertia. What is rotational analog of velocity? Rotational analog of velocity is angular velocity, okay, and there is a half. So definitely, if we just find what is the rotational analog of linear motion to angular motion, and then we will see that the correct answer is half I omega square. Now next question, we will be doing the matching now. The physical quantity which is equal to the time rate of change of angular momentum. The physical quantity which is equal to time rate of change of angular momentum is also called torque or called moment of force. Okay, so radius of gyration, power, moment of force, moment of inertia, angular acceleration, work. So as you can see, torque is not given, but moment of force is given. So it should be moment of force. Moment of force or torque, both are same. Okay, now the dash of a body about an axis may be defined as the distance from the axis of a mass point where mass is equal to the mass of the whole body and whose moment of inertia is equal to the moment of inertia about the axis. So this is the definition of radius of gyration. So correct answer for this will be radius of gyration, right? Gyration, whatever you call it, both are correct. Question number 8. The dash of a body is directly proportional to the applied torque and inversely proportional to moment of inertia. So dash of a body is directly proportional to, obviously moment of inertia will not be an answer. It will be either power, work, or angular acceleration, because it is said that in the question inversely proportional to angular momentum. So inversely proportional to moment of inertia. So that means moment of inertia itself cannot be inversely proportional to itself, right? X cannot be inversely proportional to 1 by x. That is absurd, right? So dash of a body is direct. Now for this, if you take the linear analog, we know that F is equal to ma. So A is inversely proportional to mass. Similarly, we can use the analog in case of rotational motion. Torque is equal to I alpha. Alpha is angular acceleration. So alpha is given by torque by I. So alpha is directly proportional to torque and inversely proportional to moment of inertia. So here it will be angular acceleration. It will be angular acceleration. The rotational analog of mass in linear motion is moment of inertia. So here moment of inertia will be coming. So moment of inertia is the rotational analog. The dash required to rotate a body within an angular velocity omega is tau omega, where tau is the torque. So this is the formula of rotational power. This is the formula of rotational power. F into V in linear motion and tau into omega is in rotational motion. So the power required to rotate a body with the angular velocity omega is tau omega, where tau is torque. It is called power. Okay, slightly tricky but interesting. So we have done our homework. So same thing, if it is angular tau into theta, then it could have been work. Okay, tau theta is the angular displacement. So remember that whatever you are doing in linear motion, if you take the corresponding quantities in rotational motion, you will get the same quantity, right? Now let's move on to gravitation chapter. Easy chapter. When the earth is closer to the sun, earth moves faster. Okay, earth is closer to the sun means obviously the earth will move faster. Okay, closer, distance is smaller, so that means force is more force means it will move faster. No need to check the other option. Next, which statement best describes Newton's law of gravitation? Let's see. It applies only to objects on Earth. It is limited to interactions between planets. It is applicable to all objects with mass in the universe. So that's why it is called Newton's law, universal law of gravitation, or Newton's law of gravitation is also called universal law of gravitation because it is applicable to all objects having mass in universe. Okay, so it is applicable to all objects with mass in universe. Now next, the acceleration due to gravity due to a hollow spherical shell of uniform density at a point inside is 9.8 meter per second square, same as its value on the surface, 0 more than its value at the surface. So if you consider a hollow spherical surface, so this is not inside Earth, by the way. Remember, this is not inside Earth. It is a hollow spherical shell. So suppose we have an egg, but we have taken everything inside an egg, then this is called a spherical shell. Okay, shell means just outer cover is there, nothing is inside. Okay, so if you go inside, okay, what will be the gravitational acceleration? First of all, this is not Earth, so 9.8 meter per second square is definitely not the case. Now if it is a hollow shell, when you construct something, some imaginary sphere inside, it will have zero mass. Hollow means nothing inside, so it will have zero mass. So mass zero means there will be no gravitational acceleration. So inside a hollow shell, gravitational acceleration will be zero. So correct answer is 0. Okay, now let's move on. The work required to bring a particle from unit mass from infinity to a given point is called gravitational potential energy. Okay, because it's a unit mass, it will be gravitational potential. It will be gravitational potential. If it is any mass, then it will be gravitational potential energy of the mass. Okay, otherwise it will be gravitational potential. Work required to bring a unit mass from infinity to a point is called gravitational potential of that point. Okay, now what is the value of universal gravitational constant in SI units? So even though this is a very easy question, but this came when the question paper was done by your board. Okay, so 2 years back, the final 11th paper or first PUC paper was done by Karnataka State Board, and the paper had this question. They also had unit of universal gravitational constant. So remember that 6.67 into 10 to the power of minus 11 Newton meter square per kg square is the correct unit and correct form. Okay, so make sure you answer it properly. Either unit can become or the value can become, so make sure you are answering it correctly. Now next, fill in the blanks. The acceleration due to gravity is dash at the surface of the earth. So acceleration due to gravity on the surface of the earth is maximum. So let's see the option, minimum, maximum. So obviously we got our answer, it will be maximum. The gravitational potential due to earth at a very large distance, this is question number 7, this is 8, this is 9, and this is 10. Okay, the gravitational potential due to earth at a very large distance is dash. So gravitational potential due to earth at a very large distance will be 0. So it will be 0. Gravitational potential will not be minimum, it will be 0. Very large distance, it will be almost 0. The dash of revolution of a planet Saturn around the sun is more than that of planet Jupiter. Okay, so let's see the answer. So dash of revolution. So you can say that Jupiter is very close to Earth, so that means it is rotating faster. So time period of revolution for planet Saturn will be more compared to that of Jupiter, because Saturn takes a lot of time to cover around the sun. So time period of rotation of Saturn will be more compared to Jupiter, right? Now when an object is moving under the influence of gravity, dash is not conserved. So energy or linear momentum. So because it's a rotational motion, so linear momentum is not conserved, energy will be conserved. Okay, so linear momentum is not conserved when it is moving under the action of gravity in a rotational motion. The dash of any orbiting satellite is negative because it is bound to the earth. So the energy of an orbiting satellite is negative. So if you try to calculate the energy of an orbiting satellite, it is negative because it is bound to Earth. That means you have to give that extra energy to make it free and go away. For example, there are two probes which are currently free from our gravitational acceleration and moving outside solar system. If you know the name of these two probes, please mention that in the comment below. It launched in around 1970s, and it is currently almost the furthest object, man-made object outside our Earth, okay, and they are still moving further and further away. Now let's move on. Properties of solids. Now next chapter. Statement number 1, steel is preferred over copper and aluminium in structural designs. So if you see that, we have seen some advertisement in the TV where say TMT bars, right? What is a TMT bar? Steel TMT bars, Captain TMT bars. So what are those? So those are basically steel rods. They are used in construction. So if you are residing in a house, the house is probably made using columns, and those columns have steel bars inside it. And any bridge you travel along, that bridges are made with steel rods. Okay, if you have seen the metro construction in Bangalore, they use steel rods. Okay, so steel rods are everywhere. Now why do we use steel, not copper or aluminium? One reason, basic reason, it's cost effective. That is fine, but still if it is cost effective, then if copper was better, then at least for some buildings, some people who have lot of money, they should have used copper and not steel. Now why steel is used? For everyone, not for only us. Poor people, the richest of the people, they are also using steel. Why so? Because steel is more elastic than copper and aluminium, as its Young's modulus is greater than that of copper and aluminium. So is it correct or not? So obviously statement 1 is correct. Statement 1 is correct, no doubt about it. But is it correct? So let's think rationally. So if the Young's modulus is less, then what will happen? A small force will bend it. Even a small force will bend it, right? So that means it will bend away even with a small wind. Okay, so if you are using aluminium or copper, okay, Young's modulus is less, so that means if wind blows, the building will collapse, right? That is not happening. That's why we are using steel. That means its Young's modulus must be high, right? So definitely Young's modulus is higher compared to copper and aluminium, and that's why we are using steel. So both statements are correct, and statement 2 is the correct reason, right? Sometimes even if you don't know the answer, you can use some logic behind the answer and you can answer. For example, Young's modulus, higher Young's modulus means it is very difficult to bend, even though it is very elastic, but even if you bend it, it will come back to its original position very, very quickly. Okay, so that's why it can withstand some sort of earthquake as well. Not very high level, high magnitude, but smaller level, smaller magnitude earthquake also can be handled by the columns that is built, right? Now let's move on. The stress that changes the volume of an object without changing its shape is called compressive stress, tensile stress, shear stress, hydraulic stress. So the volume is changed, but shape is not changed. So this is called compressive stress. Okay, shear stress is basically where you are applying the stress along the object, so shape changes. Hydraulic stress, the volume does not change, the only thing is the stress is transferred. Okay, and tensile stress is where it is related to solid, not of liquid. Okay, so tensile stress is when you are extending or stretching or compressing it. So it will be compressive stress where you are compressing the object but its shape remains same. Now next, after what point on the stress strain curve for a metal does the strain keeps increasing even by a reduced applied force? That is called ultimate tensile strength. That is called ultimate tensile strength. Okay, the first part where it starts to bend is called yield point. Okay, yield point means beyond that it is no longer completely elastic, even though it's still elastic, but no longer completely elastic. It will have a permanent deformation. Okay, so beyond that is called yield point, and then we have ultimate tensile strength. Proportional limit is the first part. If you observe the graph, okay, the Hooke's law graph, where the graph is like this, Okay, so this is the zone where it is tensile strength, and here it is called ultimate tensile strength. Beyond this point, even if you are decreasing the force, still small amount of force will create a large amount of strain. Okay, so strains keep on increasing, and it is called ultimate tensile strength, and after some time it breaks. That is called fracture point, where the material bends, breaks. That is called fracture point, right? Now let's move on. The approximate relationship between Young's modulus and rigidity modulus. So Young's modulus is basically given by G by 3. Okay, Young's modulus is given by G by 3. This is the approximate relation. Now next, the maximum load a wire can withstand without breaking when its length is cut into half of its original length will. So the maximum load of a wire can withstand is basically will remain same, because even though you are cutting a wire into half, okay, the material of the wire is same and the surface area is same. So it depends on the material and depends on the surface area. Okay, so if surface area is same and if the material is same, no matter what is the length, the force required to break the wire or break the material will still remain same. Okay, now next, fill in the blanks. The ratio between longitudinal stress and longitudinal strain is called, obviously we know, Young's modulus. So correct answer will be Young's modulus. You can answer this even without looking into the options, right? So dash is the shear stress per unit shear strain. So shear stress per unit shear strain is called shear modulus. It is called shear modulus. Lateral strain is equals to dash times longitudinal strain. So both are strain, so that is basically called Poisson ratio. Poisson ratio is a dimensionless quantity. It is itself is a ratio of two dimensionless quantities. Okay, so lateral strain by longitudinal strain is called Poisson ratio. The reciprocal of bulk modulus is called compressibility. It is called compressibility. Okay, Poisson ratio is also done. So a reciprocal of bulk modulus is called compressibility. Within proportionality limit, the slope of stress versus strain graph gives the modulus of elasticity. Okay, so within the elastic limit, the ratio of stress by strain is modulus of elasticity. It can be Young's modulus, it can be Bulk's modulus, right? It can be, but if it is within the elastic limit, then it will give you the modulus of elasticity. Now next, properties of fluids. The pressure in a fluid at rest is the same at all points if they are in the same height. This is the statement of Pascal's law. This is the statement of Pascal's law. Next, which one of the following statement is wrong? Solids have definite shape while liquids and gases do not have definite shape. So you have to find the wrong statement. Okay, so definitely solids have definite shape, liquids do not have definite shape, they have a definite volume. By the way, gases neither have shape nor have perfect volume. The volume of any substance depends on the pressure acting on it. Yes, for solids it may not be exactly accurate, but for liquid and gas, obviously it is correct. Solids and liquids have lower compressibility when compared to gases. So if you try to compress something, gases compress more compared to solids and liquids. When compared to solids, fluids offer large shear stress. This is wrong. Okay, solids have large shear stress. Gases generally do not have a very low shear stress because they are not at all ductile, and they are almost, their molecules are far apart, so their shear stress is very small, very low. So solids have very large shear stress compared to solids and gases. Now next question. If the area of cross section of a tube of flow decreases, then the rate of flow in the fluid through it. Okay, the area of cross section, we know that continuity equation, area times speed of flow is constant. Okay, that means if you have a large opening and if you have a smaller opening, okay, so suppose this is A1, velocity is V1, this is area A2 and velocity V2, then we will say A1 V1 should be equals to A2 V2. Obviously V1 is smaller, V2 will be larger. So if you if the cross section of the tube decreases, then velocity will increase. Okay, then the rate of flow of fluid through it will increase. So this is called rate of flow. This is rate of flow, and this is the area. Okay, this equation is called continuity equation, right? Remember it, and you might get one question. Dynamic lift is due to spinning is called Magnus effect. Dynamic spin due to spinning is called Magnus effect. So if you are someone who plays cricket, they will know that when some bowler flights a delivery, it generally goes up. That's why called flights generally goes up and goes outside the viewing thing. You have to watch the ball like this, and by the time it falls down, you will miss it and you will get clean bowled. Right now, so that is basically partially responsible reason is Magnus effect, partial responsible reason, not entirely, but anyway. So when you spin a ball, it generally tends to rise up, and that is called Magnus effect. The principle behind continuity of equation for a flow of incompressible fluid. So incompressible fluid means it does not get compressed. So the continuity equation is basically when it says because whatever, so we have seen that what is continuity equation? Area into velocity is constant. This is called continuity equation, and this is basically consequence of conservation of mass, because whatever mass is entering the pipe, the same mass should exit, right? There should not be any mass storage inside the pipe, right? So that's why continuity equation is called consequence of conservation of mass. So it is law of conservation of mass should be the correct answer. Next, drops and bubbles are spherical because of their dash property. So drops and bubbles are spherical because of the surface tension. Okay, surface tension, so because the surface tension try to bind it, and that's why drops, raindrops or water drops or bubbles that you blow away, they are all spherical because of surface tension. With increase in temperature, dash of gases increases. So with increase in temperature, viscosity of gases increases. Beyond a limiting value called critical speed, this flow of fluid becomes turbulent. So beyond the limiting speed called critical speed, any fluid becomes turbulent motion. Okay, so first one was surface tension, second one is viscosity, third one is turbulent. Okay, the force that acts on a body such as airplane wing by virtue of its motion through a fluid is called hydraulic lift, dynamic lift, open tube manometer. So this is called dynamic lift. So dynamic lift is the lift that a plane when it is moving through air, it slowly starts to lift up. That is called dynamic lift. Okay. Now a dash works on the principle of Pascal's law. So hydraulic lift is something where you apply a very small amount of force, but you can lift a very heavy object. That is called hydraulic lift. It is used in mechanic garages. Okay, so that is called hydraulic lift. Now let's move on to thermal properties. Now we are moving into thermal properties. Few more chapters left. Please be patient, stay with me. I will solve all the questions so that you are going to get the maximum possible marks in your P1 exam, right? So if you are with me till now, don't leave it, stay till the end, right? Two thin blankets keep more hotness than one blanket of thickness of equal to these two. The reason is, so if you are using a blanket, say this thickness, or you are using two blankets of total thickness equals to this. Okay, so total thickness of this is equal to total thickness of this, but you are using two blankets. This is more beneficial. This is more beneficial than this one. Why so? Because there is a small thin air gap which acts as an insulator. So this air gap acts as an extra layer of insulation, and that's why this keeps you more warm. And this is basically used in all North Indian cities. If you travel to any North Indian cities during winter where the temperature is very close to zero, you have to use two blankets and not one. Okay, remember that. So a layer of air is formed between these two blankets, which is a bad conductor or insulator, and that keeps you warm. Okay, now next, The temperature at which the same value of measurement of Celsius and Fahrenheit scale is minus 40 degrees. At minus 40 degrees, Celsius scale and Fahrenheit scale are same. Some places in the Arctic region you might get this low temperature, and yes, it is possible in Antarctica and some Russia, some region in the North Arctic as well, Russia and some other places, you will get minus 40 degrees Celsius temperature during winters. Now next, at atmospheric pressure, the water boils at 100 degrees Celsius. If the pressure is reduced, it will boil at lower temperature. So basically, if you reduce the pressure, the temperature, boiling temperature decreases. If you increase the pressure, the boiling temperature increases. Pressure cooker works in the principle where you increase the pressure, boiling point increases, so water boils at higher temperature, right? But in this case, pressure is reduced, so it will boil at a lower temperature. Okay, next, the temperature of stars is determined by Stephen's law, Wien's displacement law, Kirchhoff's law, Newton's law. So Wien's displacement law is basically states that lambda into T is constant. Okay, and this is the law which is used to determine the temperature of stars. We can measure the lambda, that is the wavelength of light coming from a star, and based on that lambda, we know the constant value can be calculated in our lab on Earth. So if you calculate lambda T, the constant is universal. So from there you can calculate what is the temperature of that distant star. Which of the substances A, B or C has the highest specific heat? The temperature versus time graph is shown. So if you see the temperature versus time graph, so as you can see, some object is gaining temperature at higher speed, some is very medium, and some is very slow. So if you consider as fixed time, if you consider this is a fixed time, so time is fixed over here. At same time, who has the higher temperature? This object has higher temperature, this object has medium temperature, this has the lowest temperature. Now if someone has higher specific heat, if some object has higher specific heat, it will heat up very slowly. For example, water, it takes some time for water to boil. Instead, if you add some salt in the water, okay, it boils faster because its specific heat decreases. Okay, so that means if for same time, if the temperature increase is smallest, this will have highest specific heat. So Z has highest specific heat, whereas X has smallest. So this is high and this is small. Okay, so Z has highest specific heat and X has smallest specific heat. Now if you see that in this question they are asking about highest specific heat, so obviously answer will be Z. So how to answer such questions? Fix the time, draw a parallel line with the y-axis on the x-axis. Okay, so that means you are fixing the time, and whoever has smallest value should have the smallest specific heat, right? Now next, fill in the blanks. Dash is the device used for measuring the quantity of heat. So what device is used? Temperature regulation, trade wind, calorimeter, sea breeze, sublimation. So it is calorimeter that is used to measure the heat, right? The dash of remember, thermometer is used to measure the temperature, calorimeter is used to measure the heat. The dash of the solid during melting remains same. So the temperature of solid remains same. So correct answer will be temperature. Okay, temperature of solid remains same. The phenomena in which refreezing of ice when pressure is removed is called regelation. Okay, so you are applying some pressure, the ice melts, and as you are removing the pressure, the ice refreezes and becomes solid again, and that phenomena is called regelation. The process of change of state directly from solid to vapor is known as sublimation. This is called sublimation. You studied about sublimation in your lower grades, right? Next, the steady wind blowing from northeast to equator near the surface of the earth is called trade wind. It is called northeast trade wind. Okay, and using this trade wind, basically the travelers, they used to travel from one part of the world to the other part, because that point of time the engine was not there. Okay, the ships used to rely on the air, and they use sails, and using that sail they used to travel from one part to another. There was no motor, there was no engine back then, and only using sails they used to travel. There was some specific trade routes through from where to where they can travel using these sails. Okay, so those who are One Piece fan, they might know how the sails work. Okay, so you have a cotton cloth, and once it is properly oriented, then you can take the trade wind and you can travel from one place to another. Right, there are certain ways obviously, but anyway, so trade wind is basically using it. The traders of the past, they used to travel. Now thermodynamics. Now next chapter, thermodynamics. Which of the accompanying PV diagrams best represents an isothermal process? Now in an isothermal process, what is an isothermal process? In isothermal process, the temperature remains constant. Okay, so the temperature remains constant means isothermal process. Adiabatic process means the heat exchange is zero, but temperature can change. Okay, so isothermal process means the temperature remains constant. So we know that ideal gas PV equals to nRT or mu RT. Let me write the new equation given in your textbook. Mu RT. Okay, mu is mole number, R is constant, ideal gas constant, and temperature is T. Now for isothermal process, this T is constant, right? So we can say PV equals to constant. So if you plot a graph of PV constant, you will get a graph like this. This is called rectangular hyperbola. Okay, so and at any point, if you see that if you take this is P, and this V, or you take this P and this V, the multiplication will be same. The area under the graph will be same. So this is the graph where PV is constant. This graph represents PV is constant. PV equals to constant. Okay, and if you see this graph, this is a graph where pressure is constant, volume is changing. So this is a isobaric process, and this is a random process. This is nothing to do with any process. If it is a graph like this, it is called isochoric process. Isochoric process means volume is constant. Isobaric process means pressure is constant. Remember, bar means pressure and core means volume. Now next, so this term sometimes can be confusing if you are not studying properly. Okay, isothermal, adiabatic, isochoric, okay, isobaric. Okay, so isothermal means temperature constant, isochoric means volume constant, isobaric means pressure constant. Iso means constant, and after that whatever term is coming based on thermal means temperature, bar means pressure, choric means volume. The work done in an adiabatic change in a gas depends only on change in its temperature, change in its volume, change in its pressure, both B and C. Now we know that from first law of thermodynamics, delta Q is equal to delta U plus delta W. Right? Work done plus internal energy change is the heat supplied. Now in an adiabatic process, du is equals to 0. So delta W equals to minus delta U. Now delta U can be calculated using a formula NCV dt. Okay, NCV dt. So this is from here, if you can calculate the work done, you will see that it is directly proportional to temperature, difference in temperature, right? So the work done in an adiabatic process depends only on change in temperature. dt is change in temperature. So you will see that work done, it's negative obviously, but it depends only on the change of temperature, not on pressure, not on volume. Now let's move on. Delta W plus delta U equals to 0 is valid for, we have just seen the question. Okay, so delta Q is 0, that means delta W plus delta U equals to delta Q. So delta Q is 0 over here. So that means it's an adiabatic process, no heat is added, temperature changes. Even though you are not adding any heat, but the process is sudden, almost instantaneous. So that's why it is called adiabatic process. Heat is not added, but temperature changes. Next, the work done in which the following process is 0. So work done is 0. So delta W equals to 0. Now what is the normal formula for delta W? General formula for work done is equal to P dV. okay, and integration. Total work done is PdV integration. So if work done is 0, either pressure has to be 0 or dV has to be 0. Either pressure has to be 0 or dV has to be 0. Now pressure 0 is not possible, okay, so only way work done can be 0 is dV equals to 0. So what is the meaning of that? dV 0 means volume is constant, so that means volume is constant. So if work done is 0, then dV has to be 0, okay, pressure cannot be 0. So the only way it is possible when volume is constant. That means it's an isochoric process. As I mentioned, isothermal means temperature changing, but change in heat is 0. Isothermal means temperature is constant. Adiabatic process means heat is 0. Isochoric means volume constant, isobaric means pressure constant. So here, as you can see, volume is constant, that means isochoric process. This is a tricky question. Next, for a reversible process, necessary condition is in the whole cycle the system, the loss of any type of heat energy should be 0. Yes, loss of heat energy should be 0, but here as you can see 1, A and C are correct is there. So you have to check all the options. That the process should be too fast. Actually it should be very, very slow. It should not be too fast, it should be very, very slow. The process should be slow so that the working substance should remain in thermal and mechanical equilibrium with the surrounding. This is called quasi-static process. Sometimes this is also called quasi-static process. So both A and C are correct. So correct answer is option D. Okay, so in a reversible process should be very slow so that the substance remains in the equilibrium and the energy should be conserved. Energy should be conserved, that is change in energy will be 0. Now next, fill in the blanks. 0th law of thermodynamics define the concept of, 0th law gives concept of temperature. 0th law gives the concept of temperature. The work done by the gas in adiabatic process is equals to decrease in its. So work done by a gas in adiabatic process, so work done in adiabatic process is minus delta U. So it is basically negative of or decrease of internal energy. So it will be internal energy. Okay, first answer was temperature. So whenever you are answering, fill in the blanks, as I mentioned, try to mark it so that you remember which options are already answered. So it will be internal energy. In a dash process, the work done by the gas is 0. So as we have seen in isochoric process, the work done is 0 because P delta V or P dV, dV is 0. That means it's an isochoric process. Okay. Next, the change in the internal energy of a system in a cyclic process is the change in internal energy of a system in a cyclic process. So whatever it is started, it will coming back to the same state. That means work internal energy should be 0. Change in internal energy should be 0. Okay, so 0 should be one option over here. Yes. Next, the first operation involved in a Carnot cycle. The first operation, Carnot cycle involves 4 steps, right? The first step is adiabatic expansion. First step is adiabatic expansion. Only one step is mentioned, so it will be adiabatic expansion. Okay, try to remember all the steps: first step, second step, last step. Okay. Adiabatic expansion, isothermal expansion, adiabatic compression, isothermal compression. Okay, that is the process. Now next, KTG, kinetic theory of gas. Molar specific heat at constant volume CV for a monoatomic gas. So CV generally is given by F by 2 into R. CV is given by F by 2 into R and CP is given by CV plus R. Okay, so remember these two formulas, you can answer any and every question. Okay, so or you can say that it is actually equals to F plus 2 by 2 into R. Okay, both are correct. Now CV here is monoatomic gas. What is the degree of freedom for a monoatomic gas? Monoatomic gas means only one molecule in the gas, and one molecule means it can go in the x direction, in the y direction, x, y and z direction. So 3 directions it can go, so its degrees of freedom should be equals to 3. Okay, so for monoatomic gas the degrees of freedom is 3, so its CV will be 3 by 2 R. CV will be 3 by 2 R. Next, molecules of a gas behave like inelastic rigid sphere, perfectly elastic non-rigid sphere, perfectly elastic rigid sphere, inelastic non-rigid sphere. So according to the postulates, molecules of a gas are perfectly elastic and rigid. Both are true, perfectly elastic and rigid. So correct answer is option C. Next, the RMS velocity will be greater for hydrogen, oxygen, equal for both, nothing is definite. So RMS velocity is actually inversely proportional to mass, square root of mass. So whoever has smaller mass, they will have higher RMS velocity. Okay, higher the mass, smaller is the RMS velocity. So that's why some lighter gases, hydrogen, helium, they do not present inside Earth, because what happens is that when the Earth was hot, hydrogen, helium escaped because they have very high RMS speed, which is sufficient, and it was sufficient for escape speed. Okay, so lighter the gas, higher the RMS speed. So hydrogen will have higher RMS speed compared to oxygen. Now next, a box contains n molecules of a gas. How will the pressure of the gas be affected if the number of molecules is made 2n? Suppose we have a box and here we have n number of molecules. Suddenly if you double the number, okay, what will happen to the pressure? Suppose inside your classroom there are 20 students that can sit comfortably. Suddenly in the same classroom, if 40 students comes in, what will happen to you? You will feel more pressure, the space will be squeezed, and you will be uncomfortable inside the same room, right? So that means pressure will increase. So if you increase the number of molecules, the pressure should always increase. And here, because you have exactly doubled the number, pressure should also be doubled. Pressure is directly proportional to the number of molecules present, so it should be directly doubled. Next, in the relation mu equals to PV by RT, mu is mole number, okay, or number of moles. Mu is called mole number or number of moles. Number of molecules not correct, atomic number not correct, mass number obviously not correct. It is called number of moles or mole number, mole fraction. Now, not mole fraction, mole number. Question number 6. According to dash law, equal volumes of all gases at equal temperatures and pressure have the same number of molecules. So which law we are talking about? Absolute temperature, 0 equipartition of energy, 5 mean free path, Avogadro's. So there is only one law that we have. Equipartition of energy is also kind of law, but it is a principle more than not a law. So according to Avogadro's law, equal volumes of all gases at equal temperature and pressure will have same number of molecules, and that is given by Avogadro's number equals at standard temperature and pressure 6.023 into 10 to the power 23, right? We all know that, so that is called Avogadro's number. The kinetic energy of a molecule is proportional to dash of the gas. So kinetic energy is proportional to absolute temperature of the gas. Okay, kinetic energy is directly proportional to absolute temperature of the gas. So okay, that will be the answer. In equilibrium, the total energy is equally distributed in all possible energy modes, with each mode having an average energy equal to half kBT. This is known as law of equipartition of energy. It's a principle of equipartition of energy. Law is a little bit too much anyway. So this is called equipartition of energy principle. Question number 9. The degrees of freedom for a diatomic gas. For a monoatomic gas, we have seen it can move in the x direction, in the y direction, and in the z direction. Okay, but what about diatomic gas? What is a diatomic gas? Diatomic gas, for example, oxygen, O2. So here we have two atoms of oxygen which are bound by a covalent bond. Okay, so here we have two oxygens, so basically two atoms are there, two atoms. So this atom can move along x, along y, along z, right? And this also can move along x, along y, along z, but they also have a bound. So this bound actually restricts, if one is moving, other can also move. Okay, so there are two ways to do this. Okay, first of all, this entire structure you can consider this entire structure can move in XYZ direction. Okay, so 3 degrees of freedom from here. But is it? Now, because there are 2 molecules, we can say that they are also rotating. They can rotate like this, okay, and they can rotate like this, and any other rotation can be combination of these 2 rotation. Okay, so from the rotation we have 2 more degrees of freedom, so total degrees of freedom is 5. We are ignoring the vibrational degrees of freedom. There is one more degrees of freedom, vibrational degrees of freedom. Okay, so that generally happens only in the higher temperature range. In smaller temperature range, only 5 should be sufficient. Okay, so 5 is the answer. Next, the average distance a molecule can travel without colliding. The average distance a molecule can travel without colliding is called mean free path. It is called mean free path. Okay, so everything is answered. Now let's move on to the next chapter. SHM, 2 more chapters, SHM, or sometimes it is also called oscillations and waves, right? Let's see. In SHM, restoring force is directed towards the opposite position, mean position, extreme position, origin position. So when an object is moving in SHM, okay, so this is the mean position. So when this is mean position means this is the average of all the displacement. So suppose this is oscillating like this. So when the object is here, the restoring force is acting in this direction, and the object is here, the restoring force is acting in this direction. So remember, in case of simple harmonic motion, the restoring force is always directed towards the mean position. Origin can be somewhere else as well. So origin position is not correct. Okay, generally we take origin in the mean position, but for the sake of coordinate geometry, origin can be anywhere, but mean position for a particular oscillation will be fixed, and the restoring force will always be directed towards the mean position. Okay, and if you stop the object at mean position, the object will come to a complete rest. It will not move anymore. But if you stop the object anywhere else and if you release it, it will still continue to move. Next, uniform circular motion can be seen as SHM because circular motion is oscillatory motion. SHM motions and circular motions are periodic in nature. Projection of a circular motion on its diameter executes SHM, none of this. So if you take that projection of an object, okay, on a wall, and if it is rotating in a circular motion, you will see that the motion along the wall is basically a simple straight line motion. So that is so projection of circular motion is actually an SHM. So that's why circular motion, uniform circular motion, is also considered as an SHM. So projection of circular motion actually executes a simple harmonic motion along the diameter. Now, velocity and displacement of a body executing simple harmonic motion are in phase, out of phase, have a phase difference of 90 degrees, have a phase difference of 45 degrees. So velocity and acceleration, okay, so velocity and displacement, they are always at a phase of 90 degrees. So if velocity is ahead, displacement is lagging behind. Okay, so they will generally displacement is leading, velocity is lagging, so they will always have a phase difference of 90 degrees. Next, which of the following will produce oscillatory vibration? Musical instruments, the membrane of drums, diaphragm of a telephone, all of the above. So here all of them actually produce sound, and if something is producing sound, then they are basically oscillatory vibration. Anything, any device. Right now I am producing sound because my voice box is actually vibrating, and because of that sound is being produced. You are hearing the sound because the sound box in your mobile phone that is vibrating, it's device which is installed in your device which vibrates, okay, and that actually helps to produce the sound. The maximum displacement of a body is called amplitude. The maximum displacement from the mean position is called the amplitude of the oscillation. Next, fill in the blanks. The length of second pendulum, time period maximum 1 meter, minimum 1 second, infinity. So only one distance is given, so 1 meter is the length of second pendulum. Remember, if the time period is 1 second, the length of the pendulum should be at least 1 meter, exactly 1 meter. The kinetic energy of a simple pendulum at extreme position is, the kinetic energy of simple pendulum at its extreme position is almost 0. Now here 0 is not given, only minimum is given. So at extreme position the kinetic energy will be minimum. Kinetic energy at the extreme position is minimum and potential energy is maximum. At the mean position, okay, kinetic energy is maximum, potential energy is minimum. The reciprocal of frequency is called time period. Reciprocal of frequency is called time period. The potential energy of a simple pendulum at extreme position. So kinetic energy at extreme position is minimum, so potential energy should be maximum. Okay. The number of oscillations for dash is called frequency. Okay. So number of oscillations for 1 second is called frequency. Okay. So number of oscillations for 1 second is called frequency of oscillation. Okay, this chapter is done. Last chapter, waves. Velocity of a transverse wave in a stretched wire depends on tension of the wire, mass per unit length of the wire, radius of the wire, all of the above. So it is basically all of the above. It depends on the tension of the wire, depends on the mass per unit length of the wire, and if the wire is thin or thick, based on that velocity can change. So it also depends on the radius of the wire. So all of the above is correct answer. Even though in the formula you will see these two quantities, but radius of the wire is considered constant. Okay, so if radius of the wire changes, velocity will also change. So radius of the wire is also involved. As a constant, it is involved. Now next, mechanical transverse waves can propagate only in gases and liquids, medium with shear modulus of elasticity, vacuum. So mechanical transverse wave cannot travel through vacuum. It only travel where there is a shear modulus is there. Okay, so if the shear modulus is very low, it will not be able to travel. So medium with shear modulus. Shear modulus means you are applying some pressure, it is compressing. Okay, and that's how it propagates. Okay, mechanical transverse wave can propagate only through the medium where shear modulus is there. The minimum distance between two consecutive points having non-zero phase difference is. So minimum distance between two consecutive points having, zero phase difference. So here we have, okay, so here as you can see, these 2 points have zero phase difference. These 2 points have, these points have pi by 2 phase difference, these two have zero phase difference, and this is the distance called lambda, the wavelength of the wave. So the distance between two consecutive points having zero phase difference is called wavelength lambda. Now next, demonstrate the phenomena of beats. We need two sources which produces waves of nearly same frequency, two sources which produces waves of exactly same frequency, two sources which produces waves of exactly same wavelength, two sources which produces waves of exactly same frequency and constant phase difference. So to observe beat frequency is basically difference in the frequency of two sources, and the difference should be less than 10 Hz. Okay, so if the difference is small, so that means they are very close to each other but not exactly same. Two sources which produces waves of nearly same frequency. Suppose one is 250, another one is 245, then you can hear the beat. If it is one is 250, another one is also 250, both are producing same frequency, that means beat frequency is 0, you will not be able to hear beat. So beat, that means the beat that you hear in the sounds also, songs. Okay, so you say that give me the beat. So beat is basically the difference in frequency. Closer the two frequencies are, stronger is the beat. Now next, this is question number 5, I think. The speed of sound in a medium depends on its elasticity as well as inertia, its elasticity but not its inertia but not in its elasticity, neither elasticity nor inertia. So speed of sound in a medium depends on its elasticity as well as its inertia. Speed of sound depends on elasticity as well as inertia. So this was the question number 5. Now next, nodes are points at which the amplitude is sound, light decreases, resonance increases, zero energy. So at a node the displacement is 0. dash waves cannot travel through vacuum. So any mechanical wave cannot travel through vacuum. So here sound is a mechanical wave and it will not be able to travel through vacuum. In case of waves, dash is transferred from one point to another. So energy is transferred in case of waves from one point to another. So correct answer is energy. As temperature decreases, the velocity of sound decreases by Laplace's correction. So if temperature decreases, the velocity of sound is also decreasing. If the external frequency is close to one of the natural frequency, so decrease is correct. So if external frequency is close to one of the natural frequency of the system, then system attains resonance condition. So this is called resonance condition. At resonance, the external frequency and the internal frequency, if they matches, then the object oscillates much faster, and that condition is called resonance condition. Right, so this is the end of all 1 marker session, but I will be back with all 2-3 marker as well as all 5 marker questions very soon. So if you have not yet subscribed to our channel, don't forget to subscribe to our channel, and obviously share our channel with your friends so that they can also study and learn together. Right, I'll be back. Till then, bye.